Hello, so I'm going to be giving a quick explanation of how breadth first search works. So let's assume we have a graph like this and we want to run breadth first search on it. Basically, the first thing you want to do is, well, in breadth first search we use a queue. So let's say we have a queue such as this, and we have to, start from somewhere. So maybe in your BFS implementation, you let the user pick a source. So let's just pick a source of say 1. So I'm just going to label it S, which means source. So the first thing you do is you start with your source. You put your source in the queue. So we put 1 here, and you should remember in a queue is first in, first out. Basically, whatever comes in first is the first thing that gets out of the queue. So we insert 1 into the queue and we mark 1 as visited. Yeah. Now the idea here is if a vertex has been visited already, we don't add it to the queue anymore. If not, if we don't do it that way, then we would always continue adding numbers into the queue, and that would make no sense really. So first we add 1 to the queue, and then we just go through the vertices, and we check what vertices are connected to 1. So the idea here is whenever you add any vertex, or whenever you're looking at a vertex, of which in this case we would always look at the head of the queue, and whenever we do that, we check every vertex adjacent to it. So now we check 2 is adjacent to 1 and 5. So we place 2 and 5 into the queue. So we have 2, we have 5. And each time we're looking, we pop out the vertex. So now 1 is already visited, but we pop it out. So I'm just going to put a P here. It's been popped out. And next we go to 2, because now 2 is going to be the head, right? And of course, when we place 2 and 5 into the queue, we mark them as visited, visited. And now we're 2 is the head, right? So we check 2. 2, what vertices are adjacent to 2? Now we have 4 and we have 3, and we also have 1. Now we can't place 1 into the queue anymore, because like I said, we don't add a queue, a vertex that has been visited already. So as you can see, 1 has been visited, we don't add it. What about 3? 3 is not. So we add 3 into the queue, we mark it as visited. 4, we add 4 into the queue, and we also mark it as visited. And of course, while we're looking at 2, we already popped it out. So oh well, I guess, sorry, we remove it. So let's just change this to R. So we removed it from the queue. Now the next vertex we're going to check is going to be 5, which is now the head. So I'm just going to start. This was head 0, this was head 1, this was head 2. So now when we get to 5, which when we check 5, we already removed it. And now 5 is adjacent to 1. 1 has been visited. 5 is adjacent to 4. It's been visited already. So we move to the next one, and we check. Okay, now head 3 is 3. We remove it, and we continue performing all these operations as long as the queue is not empty. So when we check 3 is adjacent to 2 and it's adjacent to 4. As you can see, 2 has been visited already, 4 has been visited already, as you can see them, but here, and we just, remove it, and then we go to the next vertex, which is 4. When we get to 4, we check 5 has been visited, we check 2 has been visited, we check 3, it's been visited already, and we remove this, and this was head 4. And as you can see, now our queue is empty, and we have the order in which we visited the vertices. So the order is just 1, 2, 5, 3, and 4. Thanks for watching this. In my next video, I'm going to show how to actually find the shortest path with just breadth first search algorithm.